Okay, thank you so much for being here. I'm going to walk around the room a little bit. I think the ceiling mic is on, so hopefully everyone can hear me online. Nia is monitoring the team's chat out of the room as well. Lovely to have a full room, and thanks also for those of you joining online. Great to see a bunch of different industry partners, so really welcome to have you here. This lot is recorded so that anything I do say can be given in evidence. But I have a couple of pens and I have some papers for the people in the room. I've just maybe asked, would one person in each room be willing to possibly fill out a piece of paper as you go along? Just because I'd like to maybe ask the room some questions. So there's some pens and paper. If anyone wants to jot down some notes, because in the middle of my talk I do have lots of numbers, and it'll enable us to pick on some of these threads at the end. So. And I was going to start, rather than a slide to start with the drainage system, I was going to start with one of those musicians who's both doing the tambourine and the drum and the triangle and the guitar and singing at the same time. So I shall introduce myself, because it's a session that I would do the introduction for. So I'm an associate professor. I'm Peter Melville-Shreeve, University of Exeter. I'm part of the Centre for Water Systems. I have the pleasure of engaging with CREW's research steering group. I run a small team of researchers which we refer to as a stormwater intelligence group, as a subset of the Centre for Water Systems. And Albert said, we've got a slot in a couple of weeks' time, would you like to fill it? I thought, well, it's a good opportunity to frame a few things, get some feedback before maybe turning this into something to present in the summer. So, feedback welcome. I've asked both Mandy and Gavin in the room to flag if I use language that makes no sense along the way. So hopefully I'm going to try and aim at a general audience. Those of you who are consultants and know more than me, please interrupt and introduce knowledge along the way. Welcome, welcome. Okay, let's dive in. Okay, so I thought I'd frame things by thinking about the is it cake model. Netflix, okay, and here's a cake in the shape of the Mona Lisa. And the question on the project, on the Netflix TV show is whether or not anything they make is in fact cake. And I thought we would use that as a lens to think about SuDS. Whether or not they actually are SuDS as we go through. So, is it cake is my thinking, and this one is in fact cake. It's a Mona Lisa in the shape of cake. And here is a surface water drainage release. And my kind of point is, we know it's cake, because when we cut through it, it tastes like cake, and we can use our sensors in our mouth in the form of our tongue to inform us that it is cake, and we can be pleased with ourselves that we've made cake. But with stormwater systems, we don't necessarily have a tongue sticking out the end of every part of our SuDS train. So if we don't put the tongue in, how are we to taste whether or not the SuDS are in fact cake? So hopefully you're with me on my analogy. Left-hand side is a manhole chamber on campus that I'll come back to later, in which I like to think we have installed a tongue, keeping an eye on what's going on in the SuDS there. If we don't have a tongue, we of course can't gather data from our devices. We don't have data, we don't know how they're performing. We don't know how they're performing. We don't know whether or not the jam in the middle of the cake tastes delicious or is not quite what we hoped it to be. Okay, so I sat down with a couple of colleagues in my team and we explored kind of where to start. And unfortunately, I realised I've been thinking roughly about this talk for about 10 years. And might well be thinking about it some more in 10 years' time. But we worked with CIWEM about 10 years ago, 2015, to pull together a 2016 paper in which we got 539 responses from CIWEM's readership related to the state of SuDS delivery. And you'll be pleased to know I haven't copied and pasted all of it in here, but I've got a couple of slides just to reflect on the conclusions back from 2015-2016 era, so a decade ago. And as part of this, it recommends that we should be including high quality SuDS with adoption and maintenance coordinated by a single body, the lead local flood authority, under this kind of framework. Mandatory standards should be enforced. Greener SuDS, which provide amenity, biodiversity and water quality benefits, should be incentivised. So just to highlight, high quality SuDS should be incentivised. We used that as an opportunity to have a look at monitoring in SuDS, and a quarter of the respondees 10 years ago agreed that monitoring would be interesting, and I'm here still championing the journey towards monitoring more SuDS so that we can taste that cake. But experts overwhelmingly support the adoption and ownership of SuDS. The primary barrier to SuDS implementation is around adoption and long-term ownership. Policy changes, additional resources, capacity in the local authority and SuDS incentives will be required to achieve these uptake. and the perceived costs of SuDS might be hindering implementation. Further research is needed to provide kind of a further view of these related to costs and benefits. Okay, so we took the findings of that paper and some other research that was ongoing at the time, and here's me with a bit more hair 10 years ago or there or thereabouts with CIWEM, who were one of the organisations in the centre of this domain, and we took it to the Climate Change Committee in 2017, encouraging people to think about climate adaptation and how SuDS can fit into this, how stormwater management fits into this domain. So what was the norm for SuDS in 2015, according to the evidence from that paper? Well, an illustration of a site that I actually did design work on in the early 2010s, which is in Taunton, and typical of most sustainable drainage at the time, we have an attenuation tank underneath the playground. This is good because some might argue it's dual use. We can turn the playground into a storage area and have a playground on top of it. And then we have attenuation ponds running through the site. Unfortunately, from my personal perspective, when we started the design of this development, it was going to be swales and rain gardens and the like. And as we kind of drove through to detailed design, we left some of those behind and went for the what might be considered value engineering options to go for attenuation tanks and ponds. And so the answer of kind of what most SuDS, and some people will argue with me as to whether or not they're considered to be SuDS if they're not soft and green and have high amenity value. But I'm going to use that phrase throughout. We're going to still call them SuDS. So what was the norm in 2015? Mostly we did tanks and ponds, occasionally green roofs, rainwater harvesting, biodiverse rain gardens, etc. So attenuation ponds and tanks that can release during storms, because we have passive flow controls on these releasing stormwater during storms. Okay, that's my overall intro. So now we're going to play a quick game of Name the Inventor. Does anyone in the room know the inventor? Edison. Excellent. Without even needing to find out his famous phrase, I find out what the world needs, and then I go ahead and try and invent it. So as much as some of the things that I've designed in the past might be wonderful, and I might try and push those wonderful solutions upon others, it's great to empathise with reality, isn't it? It's great to understand what the world really needs and offer that, rather than offer what it is that we have that's available. As I go through this, you can now see Edison has his table nicely stamped up. We no longer get those issued at the University of Exeter. I'm looking forward to a desk with my name imprinted in it. And obviously he's famous for the invention of the light bulb. He didn't invent the light bulb because he thought it might be a great thing to have. He thought it was a great thing that everyone might need. So I thought I would apply that in framing this talk. There are some people online and there are some people in the room that probably know a lot more than me, so I'm hoping they might prod and probe as we go along. But I asked LinkedIn and colleagues in our networks to give me some feedback as to what to cover in the talk this morning. I think I had maybe 18 responses from a kindly bunch. I can see a couple of them are also online, so apologies if I haven't picked on your response. But we've got Matthew Moore from Anglian Water, Pete Robinson is a consultant. We've got a gentleman, Ed Rolson from academia, Tom Palmer, who's a local authority officer, and Martin Osborne. I think I spotted you online, Martin. Welcome. And another consultant and expert in this domain. So I've taken these LinkedIn items, and we're going to just walk through them for a minute or two to pull out what I see the threads to be. So if we go for Martin's one, he's saying that if we don't fully implement SuDS and rainwater reuse, what's the minimum that we should require to simplify later retrofit? So I'm going to frame that as what would suffice as minimum. Ed and Tom I've gathered together into this theme of how to achieve multiple benefits. From Matt Moore at Anglian Water, I've gone with how can we make great SuDS the norm? And I know kind of making things great again is probably not a trendy phrase, but we don't want to just make SuDS the norm. SuDS are the norm, and we argue about what that means. We want to make great SuDS, don't we? So. And finally, from Peter Robinson, sort of how do we aim for less to achieve more? So he's asking this question: how do we get comfortable with achieving 75% rather than trying to achieve 100%? And this might make a bit more sense as we look at a case study in a minute. But if we've got stormwater runoff arriving at a site and we're trying to manage that 100% of the time over a 100-year window, allowing for climate change, we design one thing. But if we tried to manage it 75% of the time, we'd be designing something else. And I suppose the question is, which of these two things is more useful to society in a world where we have stormwater overflows that we're trying to manage and downstream flooding that might increase as climate adaptation continues to change our rainfall. So 4 themes that I'm going to come back to at the end, which I like to see as being extracted from the experts in my LinkedIn network, and I'll reflect back on again at the end. And I'm hoping again people will challenge me on some of these things, because I'd like this to be the beginning of a journey towards reframing some of my own personal thinking in this. Okay, so are we making the most of SuDS? So before we can address those 4 themes, we need to know what's true today. So we've moved on from 2015, where largely attenuation tanks and stormwater ponds were the bulk of the attenuation methods, as shown here in this development, which incidentally was called King Lake, once the PR team saw these images of the lakes adjacent to the design. They're designed to fill up during the 1 in 100 year storm, which occurs on average once every 36,500 days. And so there's now a couple of hundred people living next to living in a development site called King Lake, but the lake only fills 1 day every 100 years. So slightly disappointing perhaps if you're the person that bought a house thinking you'd be next to a lake, but at least you do have some nice amenity land nearby. So the blue bit is the kind of 100-year flood level rather than the daily flood level. Okay, so what's true today? Attenuation ponds and tanks still appear to be prevalent. But I think it would be really interesting for someone somewhere to do a study to go and find out what the truth is, perhaps trawl through 1,000 planning records to see what 1,000 planning records tell us the final attenuation solutions are, or given developments since, say, 2020. An interesting piece of research I think that could be. We used to use micro-drainage. Micro-drainage has been bought by InfoWorks. InfoWorks has been bought by AutoCAD. Personally, I don't have either of these on my laptop today to play with, but micro-drainage was familiar a decade ago. I can see some people in the room that probably are familiar with micro-drainage, but we used to design attenuation systems with these, and we would end up with some form of GRP or geocellular storage product as our main attenuation. So I think still today we're in this domain, but I haven't got evidence to back this up, and in some ways I'm kind of calling for people that could help us look at if that is a valid hypothesis. So why don't we install more blue-green SuDS and less of the enormous attenuation tanks? EATS is what I've got for here. So let's have a look at clues in an up-to-date case study. Okay. So 15 minutes in, I think I've now fully wrapped up my introduction. I'm going for content warning at this stage. So for those of you who haven't had coffee, at this stage we want to go from zone A for like thinking about analogy, and we're diving into zone B if we're in Daniel Kahneman's book. So we're into a thinking slow stage, and I'm going to run through it. And the reason I've given out some sheets of paper and hopefully a few pens is I'm hoping a couple of you in the room will keep an eye on the data as we go along, because I've done my best myself, but I may well get lost. Okay. So, introducing case number 00001 of the SuDS Police, and we're going to take a look at an existing recent development site, which we've been following with great excitement in the Melville-Shreeve household, and I'll talk to people afterwards if they're particularly interested in why, but it will lead to low-cost croissants being available closer to my house than ever before, and we're very excited. But there are 185 planning documents available on the local planning authority's website, which I have had the pleasure of trawling through the relevant ones line by line in order to produce the content that's coming. So, nearby in Crediton, there is a rugby club with a greenfield site, which will soon become a small supermarket. And if we dive into the flood risk assessment and the drainage strategy, and those of you in the room might well have had a look at, might have provided these in the past, but there's the National Planning Policy Framework. It insists that any site more than 1 hectare, this site is 1.3 hectares, it must have a drainage strategy and a flood risk assessment lodged with the planning application alongside the other 185 documents. In this, we find that during the 1 in 100 year storm, and this is a number that we might want to write down on our pieces of paper, the greenfield runoff rate is estimated to be 2.54 litres per second across a 1.3 hectare site. Meanwhile, the 1 in 2 year runoff rate is 0.82. Proposed development will bring us, instead of rugby, will bring us 6,825 metres squared of impermeable surfaces, roofs and car parking, but they will lead to lower priced croissants in due course. Okay, stage 1 complete. That was the greenfield site. Next up, I've trawled through the 60-page drainage strategy report and pulled out this couple of paragraphs here on what the other SuDS options are that were considered before the final SuDS were selected for this site. 3 paragraphs in 60 pages cover off the possibility of swales, detention basins and ponds. I would point out that none of those are easy to park in or on, so those ones are slightly ruled out for a development site like this. Rainwater harvesting is ruled out within a couple of sentences. They could be incorporated in the final design, but they're considered to have limited value in the context of this development. And then green roofs are ruled out on some fairly sensible structural reasons. So they're going to have solar panels on the roof, and upgrading the roof for green roof design would be a significant structural addition in cost. Okay, so therefore, at initial planning stage in the year 2020, we end up with an estimated storage requirement of 203 metres cubed for the 1 in 30-year storm. Another number might be worth scribbling down if you have a piece of paper, and 424 metres cubed for the 1 in 100 plus 40% climate change event. For those not indoctrinated in the land of drainage design on new developments, we allow an additional 40% uplift in rainfall intensity for a projection that this site will still be operational selling croissants in 100 years' time, when the intensity of rainfall could be up to 40% higher from climate change projections. What that means is we're over-designing for today, and we're building bigger storage than we might necessarily require in the first 10 or 20 years of the development, but we're making space for the future. And in this case, we're looking at an attenuation tank with a design head and a hydro brake. Okay, so the preferred scheme will, I'm just going to dive back here, no, I won't go dive back. Can anyone remind me what the 1 in 1 year greenfield runoff rate was for the site for 100 year? 2.5 something, okay, 2.5. Okay, so in the preferred drainage scheme, we're aiming to achieve greenfield runoff rates. But the report is now aiming at 4 litres per second, which we may or may not see as a number that does or doesn't match 2.54. We may or may not see it as a number that's higher than 2.54. A lower rate than 4 litres per second may result in a potential surcharge of the proposed attenuation structure should a subsequent rainfall event occur following a peak event. Just going to let that one be pondered on. But that's the reason that we're going for 4 litres per second. So we were aiming at 2.54, but now we've got a sentence that tells us why we're going for 4. So we're moving forwards with 4. And 424 metres cubed of storage. And I borrowed an image from Graph to illustrate what the storage can look like underneath the car park when we're finished here. But a typical attenuation crate system would be lined and installed under there. Okay, now, back in the olden days when I was designing these things, quite often we would put in a 5 litre per second discharge rate as our minimum discharge. And the argument would be that if we put in a smaller flow control than that, and we're talking about an orifice in a chamber controlling the tank, we're thinking about kind of a bathtub that needs to drain slowly after a storm once it's filled up with the 100-year storm event, we would historically be permitted to aim at 5 litres per second. However, innovation in the last 20 years has meant that we're moving to slightly smaller devices, and the flow controls available on the market can get down to around about 1 litre per second, depending on the design head. So Devon County Council have upgraded their guidance in the last 10-15 years to point to the National SuDS Manual, of which there are 968 pages if anyone wishes to digest in full. But the National SuDS Manual tells us that we can't go for 5 litres per second as our minimum discharge rate anymore, because modern flow controls can facilitate lower discharge rates. And so at planning stage, we end up with this attenuation device here, which is a single large attenuation storage tank with a single flow control and all runoff from all roofs and all drainage all brought to a single location. From an engineering perspective and a least cost perspective, it makes total sense. It's going to provide plenty of storage. It's going to slow down the flow back down towards greenfield runoff rates. And micro drainage calculation. All of this is from the planning website, by the way, in terms of everything that I'm showing you here. It's all open source. But the planning micro drainage calculations tells us that if we didn't put attenuation on site and we have the 100-year storm, we would expect a hydrograph with a 32 litre per second discharge rate. So we've gone from 2.5 as greenfield up to 32 if we do nothing, which would have happened up until 2005, maybe 2000, as the first planning guidance came in that forced us, under PPG 25 and then PPS 25, forced us to install attenuation systems in the UK alongside every sizable development. And red line here is what would happen when the 100-year storm event comes. We would stay under 5 litres per second discharge for the whole storm, and it would discharge over 2,880 minutes. And those softwares take the critical design storm. So if it was a 15-minute storm event that causes you your worst scenario, it would use that. In these sorts of ones, we often end up with a 360-minute or 720-minute storm, gives us the biggest volume that we need to manage. Okay, attenuation tank under the car park. That's the headline. Approved. Well done, team. First 100 documents on the planning website. 2020-ish, we get approval, we can move forwards. So next, we have to move into the detailed design, and we have to address our planning conditions. We're about 2/3 of the way through the thinking stage for everyone who's running out of thinking capacity. So we've got to get through our planning conditions now. So there's a planning condition in here which essentially says you cannot occupy the site until such time as you built the thing you promised to build. What we promised to build was 424 metres cubed, 4 litres per second control as an attenuation tank. So now we move into the next phase, and a new set of designs are provided with detailed designs, and at this stage we've got a 366 metre cube, might be a number for the piece of paper, metre cube tank that will be taken forwards into our final design calculations. And I don't want to spend too much time labouring this, but all of the details are available. They're handed into the lead local flood authority, and the drainage expert at the lead local flood authority, which in this case is Devon County Council, will assess the data that's provided from these drainage calculations. So that sheet that I just showed you there is the headline design, which is a 1 metre deep tank, 385 metres squared, giving a 366 metre cube volume. And then under different design scenarios, these storm events here, we've got the 100-year storm event, and I've dropped in a 1-year storm event to talk about here too, but 100-year storm event plus 40% for climate change will give us these outcomes. So we've got maximum flow all the way through to maximum outflow. And these are at different drainage manholes, outfall, S2, dock, S3, different locations across the site. Now the only one that's interesting is the only one that matters to the local flood authority is the outfall, which is where the drainage is coming out of the site. And if we come across the outfall, we've got maximum outflow that has to be within 4 litres per second, but we have 4.4, so it's 10% over, but you know, there or thereabouts. We also have this discharge volume, so this is the volume that's coming out during the storm event, 98 metres cubed. That's not the stored volume, it's the discharge volume. So in the 100-year storm, we now have 198 metres cubed of runoff coming off the site, whilst controlling it to 4 litres per second, 4.4 litres per second. So is that the same amount of runoff that would have come off the rugby field as it was 5 years ago? That's the question. So 4.4. I would also point out that when we put one control system into these drainage devices, we can only have one outcome. So we design for the 1 in 100-year storm, but when the 1 in 1 year storm comes, which is obviously happening on average once per annum, the discharge rate has to be quite similar. We've only got one flow control. We don't have multiple flow controls. So the discharge rate for the 1 in 1 year for the new design is 3.8. And if we go back to the greenfield runoff, we didn't actually have a 1 year data set there. We had a 1 in 2 year, and that was down at 0.82. So we've more than quadrupled the discharge rate. I'd like to point out all of this is completely within expectation, within the design guides, and what is the norm. I'm just making sure we all understand what is the norm. Okay, and so for that 1 in 1 year event is now discharging maybe 4 or 5 times faster than would have done as a greenfield event. There it is, 0.82. And we've got 198 metres cubed of runoff projected during the 1 in 100 year storm. Well, I just did a quick Excel spreadsheet for this one. So if we look back on 0.82, sorry, what have we done here? We've done minutes turned to seconds, so we've multiplied minutes by 60. We've multiplied that by litres to get the 1 in 1 year discharge, sorry, the 1 in 2 year discharge volume from the existing site at 17.7 metres cubed. So today the greenfield runoff rate during the 1 in 2 year storm, which should be more than the 1 in 1 year storm, but we haven't got the numbers for the 1 in 1 year, will be 17 metres cubed, but the future 1 in 1 year storm is going to be 97 metres cubed. 97 is more? So significantly more, but still within the design standards. So, we end up with slightly reduced attenuation storage than was at the original design stage, and I think we can accommodate that. The 4 litres per second is at 4.4, 10%, give or take. It's probably reduced the size a bit. We might assume a metre cube of storage is between £1,000, £2,000, £3,000 worth of cost to a developer. If we allow for muck away and these different factors, it can be really complicated. But we've gone from a 400 and something metre cube tank down to a 300 and something. It's probably saved tens of thousands of pounds in terms of commercial cost. I don't think that's the reason that's happened. It's just detailed design as they focus into the better outcome. Anyhow, so we end up with a 362 metre cube tank in the final design, and a couple of photos of the final solution that's emerged here. So we end up with, I think 70% of the site is now paved, and as you can see, the car park there's an attenuation tank underneath the car park. And if we play the is it cake game at this stage, really hard to tell if this is cake. Right? Is there an attenuation tank underneath the car park? We know from the design drawing it's there. We should be able to see from an as-built drawing it's there. There will be a bunch of paperwork between the designers and the implementers related to the costs and the installation. We could turn up and watch it being installed, but the lead local flood authority has limited capacity to be out doing building control monitoring. So I think in this case we can definitely assume it has been installed, it is underneath there. But one of my kind of is it cake moments on this is we need to do a better job of making sure that things are cake, to stick with my analogy. So it would be great if we could see this was SuDS. If it was a swale or a pond, really easy to see. I could take a photo and we could say tick. If it's an attenuation tank, we probably need to be doing more to make sure that we're getting what we want from these things. Okay, and like I said, there was 183 planning documents when I started. There's now 185. The site isn't quite open. And very excitingly, it's because the lead local flood authority's paperwork is catching up on the attenuation systems. And actually, I think maybe 10 years ago, the site would be open and would be off and away. But the paperwork related to the drainage systems on site, this was updated just a few days ago, has been the thing, the SuDS police, if you will, the local authority SuDS police, has been the thing that's been holding up final opening, according to some of the paperwork online. Now, that's all I can see from that perspective. But they're essentially saying the local authority is now happy, the tank sizes have changed, they're slightly smaller, slightly different location, and they've received their maintenance plan. Okay. The thing the lead local flood authority was asked to look at in that final stage was the changes between the original design and the final design. And the offer that's made here is that the original design was done in one software, and info drainage is a better software, and it's making it possible to slightly change the design. I will make no comments further in relation to that statement, but that is the argument put forward that that goes alongside. So I can see some puzzled faces in the room. Okay, so preliminary findings. This is SuDS Police case number 00001, and it could be the first and last of this series of SuDS Police activities, depending on feedback. Preliminary case findings. Were the greenfield runoff rates achieved for all storms? 1 in 1 year storm, 1 in 100 year storm? I'm getting some shaking heads. We've gone from 0.82 for greenfield runoff for the 1 in 2 up to 3.8. We've gone from 17 metres cubed of runoff for greenfield runoff up to 97 metres cubed of runoff. Did we achieve multiple benefits? Can anyone find me a multiple? We've done our attenuation. Have we done any water quality improvement? There is an oil separator, so I'll tick the engineered oil separator box for the car park. Have we got biodiversity benefit? Did we manage to do any water reuse? But we have achieved quantity, and we've managed to do the quantity SuDS element, we've controlled that. But we haven't got multiple benefits. Go on, Chris.
Sorry, what was the total area of the site?
1.3 hectares.
1.3, so if it's over a hectare, doesn't it need to have a biodiversity net gain?
It was done in 2020. When does that come in? Biodiversity net gain?
No, it's slipped.
Could be an expert online that might want to give us an answer to that.
It's more recent.
More recent? Okay. Water reuse use was disregarded at first planning stage. We don't need to use water on this site, so we won't have a rainwater harvesting system integrated. And okay, SuDS monitoring not mentioned. Why would it not be mentioned? 2015 SuDS manual doesn't mention it, so it doesn't require it. We don't need to monitor these devices. There's a minimal requirement to check that this is cake. Okay, as long as it says it's cake on the drawings, we'll stick with that. Okay, yes, so this, I'd just like to recap. I've reviewed 185 planning documents. I haven't read all of them, obviously I've read the ones that are relevant to drainage. And I've run you through, line by line, the approval process, and I just want to be clear, everything within that approval process appears to me to be spot on. So I'm not at any point suggesting that anything is out of line, I'm just explaining how drainage is managed on new build developments in a typical high impermeable area scenario. Okay, because if we started getting rid of car parking spaces, we're minimising the ability for us to make profit at our future supermarket destination. So these are all sensible engineering decisions that lead us to where we're at. Okay, so this is probably the important bit. What happens if all the rugby places are replaced with SuDS? And where could we look to see what might happen in this regard? We can go to page 39 of the SuDS manual, and we can take a look at the point hydrograph drawing here. Okay, so I'm just going to whiz through my animations here. Imagine that we carry on building out the rest of the rugby pitches here. This is zone 1, 2, 3. In this scenario on the left-hand side, we've got 5 different subcatchments. What we used to have as pre-development runoff were the blue lines, which are all running at greenfield runoff rates. But as we build these systems into ponds or other attenuation features, and then we have single flow control discharges, we can only have 1 discharge rate per site. And as we start to stack these across our catchment, we're stacking up increasing runoff rates. So we've got 3.8 litres per second was the magic number for the 1 in 1 year output. Before it was 0.82. If we start stacking that across each of our development sites in an area, we can see how the runoff rates coming down into our sewer network are being increased over time. All within the policy, but they are being increased. And it's addressed in the Serious SuDS manual. Just to flag up a bit, so with natural soil conditions, the runoff from the majority of such events, with a total depth of say 5 millimetres of less or less, so your typical 1 month storm perhaps, would have been lost through infiltration or evaporation. So 0 discharge would have been greenfield runoff rate for those small ones. Runoff from these frequent small events will usually just pass through attenuation systems with limited or no control. And that's because we've got a single flow control at the end of the system. And as we stack these over time, we end up with an increased runoff rate coming downstream. Okay, case study complete. Okay, so what can the future taste like? So how do we make sure we taste the cake in the future? So one of the things I'm driving towards is to try and get campus into more of a living laboratory type status, but also reaching beyond campus and into anyone that's out there that's willing. We're looking to just get more monitoring data. So we have a large attenuation tank at the top of campus. We already have some rain gauges on campus providing 15-minute data, which can be available to all. Open source, lives on the Emery roof, it's Googleable. We're going to go in and test some other low-cost rain gauges against that in due course, because there's an argument as to whether or not we could only use high-quality British standard rain gauges or lower-cost citizen science rain gauges are useful. In the crew building, it's aiming at water neutrality, so we're carefully monitoring all of the water demands on the new crew building, with a vision to offset any additional water demands on that. So there's monitoring on our drinking water and wastewater networks. There's been monitoring on the propyl flushing toilets on campus in the past and other CCTV. So we've got these kind of baseline data sets on campus. And what we now have, the image at the top there is the car park at the top of campus. One might argue a multi-purpose car park, because it has a solar panel on the roof and an attenuation tank underneath it. But the attenuation tank downstream's got some monitoring on it, so we can see how that's performing. Because everything I've just shown you about the new supermarket site is all paperwork. It's all, this is how it's designed, this is how we think it should work. Whereas the plot that you're seeing in the middle of the screen here is driven by empirical data. This is how we know it would work given rainfall events. And I'm saying empirical data, not monitoring data, because that's driven by a rain gauge and a roof area, a local rain gauge driving a roof area calculation, giving us the graph. But we've very recently now installed a monitoring system, so we can now establish whether or not the rain gauge is giving us useful feedback in this domain. So we can move towards tasting the cake, as it were, and monitoring how these systems perform on campus. And I just want to flag some work mostly done by Chris Sweetapple in a DEFRA project, where we've done some initial publications in this domain. And really where it all drives to is step one of SMART, is taste the cake, is make sure we know what's really happening, check this jam in the middle. And step two of SMART is to use that data and evidence to improve how we design the recipe for the cake in the future. Step three of SMART is the kind of full, whizzy, real-time control version where robots are making our cakes and they're operating themselves and what have you in the future. So, to close up, I wanted to just point at 2 or 3 good examples of other practice, because I don't want to suggest that a single case study of a supermarket represents the only sort of practice that represents best practice today. One of the LinkedIn contacts, Jo Matthews, who's a local authority integrated catchment manager. She's now with one of the water companies. Justifiably points out that if we just go to Holland, then new housing estates, they don't have surface water systems. All water is captured and reused on site. So you don't need to design an attenuation system if you're designing in great rainwater reuse. Or you could use the same budget to achieve dual benefit in that kind of situation. And she's asking what the barriers are to implementing that kind of solution in the UK. So Holland can do it well. And then an example from one of the flooding and coastal resilience innovation projects that's been funded by the Environment Agency, Blue Heart. We've got a team of Exeter researchers involved in this one and a couple of others. We now have 500 sensors feeding real-time data to our data dashboard in Eastbourne. So ambition for me later this year is to get this published so that others can dive into the data and explore how it can be used. But we have what I believe to be the most hydrologically monitored location in UK, Europe, perhaps beyond. And we're accessing real-time data there from all sorts of river gauge sensors, boreholes, fluvial levels and sewer level monitoring from the local water company. Publication emerging on that at the coming Singapore Water Congress, World Congress. Okay, within that project, what are we doing in relation to SuDS? Well, I point to a spin-out company that I'm a co-founder of, which is Our Rainwater. And Our Rainwater have got a team that have been supporting on some community engagement elements. And what you can see here is Nick in a school. And Nick, along with Tegan, Anna, Sarah, Ari, a bunch of others, have been engaging as many school kids as possible in that catchment so that they can design the attenuation systems for their schools under Department for Education funding. So it's co-created, driven by the community bottom up, in order to get as much attenuation as possible, but also get multiple benefits. So the kids will design a thing. If they include rainbows, we include rainbows. And so just by way of example, there's some nice downpipe planters that will capture and release runoff during storm events that have been installed. There's a bench along the front so you can sit down. It's the entrance to the school. And some of the kids drew this rainbow as part of their design element, and we've taken that out and engineered it in to replace their front entrance for the school. So it's got multiple benefits. It's got planting, it's got seating, it's got some of the ones have got water reuse elements, but it's attenuating the storm as a retrofit. And just to highlight some numbers here, in addition to getting the attenuation done, there are 1,381 new little rainwater champions who go out and tell their mum and dad they should do a better job of managing their runoff. And we've heard some really fun stories about the activities the feedback that we've had from this, including kids going home and explaining it to their parents. So I know when my kids nag me about things, I tend to listen. So it's a good way of kind of sharing the message around how to manage rainwater in a more sustainable manner. Okay, I promised to do this at the beginning. So I pulled out these 4 themes from the LinkedIn comments. So what should we accept as minimum? And I'm a fan of the SuDS manual, but I thought I'd just try and simplify everything back down to 4 things. So, and I'm also totally happy to be challenged. So what, and I've got my face on this because I'm owning this. This is my thinking, not anyone else's. And feel free to talk to me after it. So what should we accept as minimum? I think that we should ensure that the 1 in 1 year event is visibly managed to match actual greenfield runoff rates. I think visibly managed is quite a neat phrase here, because one way of making it visible would be to bring it above ground and have it in an attenuation planter, and we can see that's there. If it's not leaking during a storm, we can see it's not leaking during a storm. You know, we're tasting the cake every time it rains. Another way of visibly managing it would be to put a monitor on it. You can still bury it in the ground and put a monitor on it, but we want to make sure that we're visibly having data and evidence that shows us that we're controlling the 1 in 1 year storm event as well as the 1 in 100 year event. Now, why is that? A lot of these systems are upstream of combined sewer overflows, spilling perhaps once per month. So what is the point in engineering a solution upstream of those locations that only goes into action for the big 1 in 100 year storm? We want these assets to operate every time there's a 1 in 1 month storm and provide attenuation. So visibly managed is my action. What's the outcome? Perhaps 90% of all storm events, given that the smaller ones are more frequent, 90% of all storm events could be attenuated and controlled if we simply visibly manage the 1 in 1 year storm. Multiple benefits. Action. We should unlock biodiversity, groundwater recharge, or water reuse for at least an arbitrary 50% of rainwater landing on the site. So it'd be perfectly reasonable to design in that system, and for the supermarket I was looking at, it'd be quite easy to install some above ground rainwater reuse, or some infiltration devices at the back of that site. It would be an additional cost, but it might be offset by reducing the attenuation storage further downstream. If policy asked for something like that, not all of it, not let's do all 4 things, but let's do minimum 2 things, then we're going to have more benefit out of our SuDS spend. And every typical house in the UK is receiving around 2,000 litres of new attenuation storage. So there is budget being spent on this, on the 1.5 million homes we're going to build. There's lots of money being spent. So let's leverage that money to get multiple benefit. Okay, so how can we make SuDS great again? It kind of fits with my visibility thing. Why don't we monitor all SuDS post-installation for 12 months? The lead local flood authorities will require borehole monitoring, geotechnical testing, all sorts of upfront activities to maximise the quality of the design. And the minute they're installed, we presume the installation matches the design drawings. A simple 12-month monitoring study on the back of every SuDS implementation, or attenuation system, or pond, or green roof, or whatever it might be, would give us evidence as to the value for society. If we did that now, by 2027, we'd be unlocking multiple benefits, because we could then choose the best empirical solutions for all of our future sites. And the kind of mainstream builders that are building houses or supermarkets would be able to implement their learnings in an agile manner straight off the bat, 12 months later. Okay, how do we achieve less with more? I didn't really touch on this too much, but there is an increasing spend by the water companies in this domain. The drainage and wastewater management plans are causing the water companies to unlock more and more budget for retrofitting in catchments. So we're seeing more retrofit SuDS than ever before in different shapes and sizes. We need to maximise the benefit of those and harness those budgets and influence how those budgets are spent with better policy and better guidelines, because some of the water companies have got £1 billion budgets in this domain that will be unlocked in April. Okay, so the time to move on this is not tomorrow, it's now, so that we can get on with making best use of those budgets. And the forward-thinking water companies have been doing research in this domain to get themselves ready to go. But I think there's an opportunity here for us to take a step forward and come up with some simple 4-step manifesto and enable those things to happen going forwards. Okay, I've made it to the end. Are we making the most of our sustainable drainage systems? I'll go with not yet, but we can soon, as long as we do some more tasting of the cake along the way. Thanks very much. Okay, questions and challenges. I'll try and open the chat on the Teams thread. Thank you, Gavin. Go ahead.
Yeah, I'm going to put you on the spot here. I mean, you've walked us through this development, which is obviously a very long way off meeting your wish list of goals, in particular 1 and 2 there. So what could be done for that particular case to get it more in line with the 1 in 1 year events, for
Okay,
example?
well, so that's a brilliant question. I considered doing a presentation around that and be the solution. But what I decided to do is just try and frame what the 4 kind of steps would be. Thanks, Mandy. But I did go and do a site walkover from the adjacent rugby field, which is open access, with my 2 very helpful children. And I can see 2 or 3 things that would be quite easy to. I think you could even retrofit some quite simple things to that site to make it manage the 1 in 1 year storm. And they could be oversized attenuation tanks on the downpipes with small throttle controls, feeding into swales, feeding into biodiversity pits, channels, rain gardens, etc. They're just not the norm, and they're not required, and so they're not there. So there are 2 or 3 quite straightforward things that could just be added. If it was well designed, you'd be able to reduce the attenuation tank size by having some of these above ground features, and in doing so, you're getting multiple benefit. So that would be one route. There are systems out there, and there are providers on the call as well that provide them. That whole attenuation tank could be smart. It could be real-time controlled. So it isn't today, but it could be in the future. So if it was smart, it wouldn't discharge at all during the 1 in 1 year storm, because the volume of the 1 in 1 year storm doesn't fill the tank. And all you need to do is have that closed and open it after the storm. And you very kindly teed me up to point to this over here. I think I've got one of these on order from a research project. We're just waiting for approval from the Environment Agency, so we can upgrade one of the tanks on campus and start to do a demonstrator in that domain. So there are ways and means. And then there are risks and there are challenges, and then if we install a different flow control, do I need to speak to the planning officer? Do I need to apply for planning permission to change the flow control in the chamber because it's wrapped in the planning conditions? Or is it done on an email exchange so that we can try it? So we're moving into that domain as a research activity next. But there's no reason to not go back to all of these assets and upgrade them in the future to do different things. Good.
2 things. One is my interesting insights regarding how the systems or rainwater harvesting are using. Here, rainwater harvesting is used to reduce stress on the sewer systems, whereas in India we used to reduce the stress on water supply systems.
Yeah, sure.
And secondly, in terms of the financial aspect of it, to improve, I always had this question: should we design our systems for the rare events that could occur, or else design it for, put some cushion to the design period as such, a design event as such, and then pre-plan the mitigation activities for the rare events, just to promote the policy changes. Usually the governments, when they see bigger picture, but to address all the events that could occur, then they might back off immediately. Whereas if we could reduce our design standards, thereby making more financially feasible, and thereby addressing all the events if possible.
I think what you're saying is eminently sensible, and it's going to make me remind. It's Peter Robinson, this one here.
Yeah.
How do we get comfortable with achieving 75%? And what I think he's saying, what I infer he's saying is, we don't need to manage every storm for the next 100 years with this tank. We need to manage the 75% of them which are causing the combined sewer to spill, or so that it's that cost-benefit analysis that we could be doing more of. I think I agree. And on the rainwater harvesting front, if you go back to 2012, academic literature in a UK context only saw rainwater harvesting as a way of achieving an alternative water resource, and hadn't accounted for any possibility of it being a useful stormwater management tool until some of the first work by Wallingford and Kelleher and others then built on that. So we do see it in that way as well. It's just I'm seeing it as stormwater. Go on, Farzan.
I want a question about that. What does the monitoring the SuDS give us? Because we don't have any. I'm thinking about that. If we monitor the SuDS, we know that right now we install it and we monitor it. But the thing that, what do you compare with before and after? I'm thinking about that. Maybe it's better to monitor the downstream and see before installing the SuDS and after installing the SuDS what's happening, not what's going on inside the SuDS exactly.
So for these greenfield sites, we can presume there's no positive drainage before the development. So if there is a sewer network nearby that we're draining into, we would just presume that all of the runoff is informally finding its way off the site. It's not positively drained. So we don't need to monitor beforehand because we're going to presume very minimal runoff from the rugby field is finding its way in. By monitoring it post-install, we're then guaranteeing that the as-builts are matching our expectations. And I think we don't necessarily need to monitor them for 10 years or into the future. A short monitoring period would validate the kind of quality of the implementation and the benefits that are available. So it's not necessarily about making that specific attenuation system for that specific development better, because that time has gone. But the evidence would enable the designers at the big attenuation companies to iterate and move towards an alternative solution next year, if that follows. And then if you're a supermarket and you're installing 50 new supermarkets in the next 20 years, from next year onwards, you'd be pushing towards a more multi-benefit design. Does that follow? I think the other analogy is sometimes the highways engineer will sit next to the SuDS engineer, and the SuDS engineer installs a thing that's buried, and you can't taste it, in my cake analogy. But the highways engineer installs a thing that's above ground, which is a road, and if that road has a pothole on, everyone in the estate is going to be messaging the maintenance team complaining. So one of them is visible and you can taste it every day, and the other one's buried and has no flavour unless we get some monitoring.
What is the reason for constructing the SuDS this actually wide, this big in terms of the area and this shallow in terms of depth? I've designed SuDS earlier, but actually it was 4 or 5 meters deep, and it was actually in industrial sites, and there was no room for making it wider or bigger.
Mm-hmm.
Is it just for making sure that you can discharge it without using a pump, or what's the reason for?
Site constraints. Chat with Chris later, maybe.
You tend to like digging like 5 meters deep,
Yeah.
and taking that material away.
Yeah, I mean minimising dig depth. But if you have a single flow control, if we're at 2 meters of head, high flow, 1 meter of head, lower flow, right? So the shallower and wider an attenuation tank system is, just as a rule of thumb, is going to get you better flow control for smaller events than a deeper, steeper one. So obviously you've got muck away, excavation, other people on site. There's a million and one reasons to keep it shallow. And the UK attenuation tank, industry provides 4 or 5 really good products that are suitable for parking on for tens of years. So you've got multiple engineering constraints. I think is part of that.
Also, the client would be less comfortable adopting a larger crate system.
Deeper, you mean?
Yeah, get the conversations going.
But it needs a lot of material for construction. Is it concrete in walls or?
Different in everyday case, but I would have a chat. Adrian's another engineer from a local authority, not local authority, but from WSP in the room, but maybe pick up on coffee afterwards. I'm going to have a quick look at the chat function over here, because I've got a couple of questions that turn up. I don't think anyone can see it, can we? What's over here? Okay, Lorna, quite justifiably, is sharing some gold here. Right, I've been completely unscientific in anything I've done there. I've just taken my local development site that will give me croissants, and I've looked at all the planning documents. So that's not a representative view of the SuDS industry, is it? It's just representative of what new supermarket in my town looks like. Lorna is saying, why don't we, and maybe someone could, research opportunity, generate an AI tool to haul through, or it's what I said at the beginning, haul through all of the planning documents since 2020 and pull down the reality of what's been installed and implemented. Each of those would be a really useful data point. So I like that, Lorna, thank you. And you've got a thumbs up as well. Richard Behan has very kindly offered some biodiversity net gain knowledge. So Richard would be a good person to go to if you want to follow up on that. Okay, and then Dylan Francis is making a challenge, I think, here. So I noticed the dock manhole was shown to be flooding in the infra drainage extract. Where were the calculations by the local authority? Do you know if subsequent calculations were submitted? I don't know. I've gone through I've shown something from all of the documents that were available in that planning application, and I think the answer to the dock manhole, if we think this is a supermarket, there's a dock for delivering the food, the loading bay. My understanding is that's lowered so that you can then reverse up to the ground floor of the supermarket, so it's probably lower. So if that's showing us flooding in the 100-year storm, then once in 100 years on average, you wouldn't want to be parking your lorry in the dock loading bay, but it wouldn't be causing flooding off-site, so I can imagine that would be deemed to be acceptable, but it's a bit of a technical one. Lorna's asking about PNG dot joining. Yeah, and Martin Osborne is asking about kind of using rainwater on adjacent sites. So some interesting ideas in here as possibilities, and some other general sharing. So I'm conscious the room's got some people standing outside. Is there a final question from the room? Can I just say thanks to everyone that took some notes and managed to capture some numbers along the way and help me remember them. Thanks everyone online. Pleasure to have you contributing and engaging. I will wrap things up there. Thanks for being here.